Yes. Is it audible now? Just text in the chat column. Abir, Adil, Ali. All right. So in the last class, we had stopped at this point. So all these properties we had discussed, that result will be a vector. It follows anti-commutative law. Parallel vectors will be 0 and perpendicular one. Specifically, we have seen the rules. Now, in the polar form, we have seen how we have to solve, right? A, B, and then we write sine theta. Magnitude of A, magnitude of B, and sine theta. If we have a Cartesian form, present, then how do we solve it? We write I cap, J cap, K cap. All right. And then we have to see I cap, J cap, K cap, we write. And then see class, whatever are the coefficients. Like I cap has 3, J cap has 2, K cap has 1. That we have to write. All right. Everybody, please open the cameras. So what we'll do, we'll write 3, here we'll write 2, and here we'll write 1. All right. Now, see, then we have the force present. This is I cap plus 3J cap. Now look, if we have I cap, the coefficient is 1. K cap coefficient, right? Now how will we solve? Whenever you have two vectors, like I have R cross F here, for I can do one thing, cut the entire row, right? I has been cut. The entire row, entire column of I has been cut. Now what we'll do? We'll take vertically downward, means 2 into 3 first, minus 0 into 1. That's how we are going to write. Then for J cap, don't write plus, always write minus. Minus J cap. Remember this for now and other questions, that you have to write minus J cap. So I cap plus J cap plus K cap cut, and this has been cut. Now we are left with 3, 1, 1. So 3 into 3 minus 1 into 1. So again, vertically down means 3 into 3 minus vertically it means 1 into plus K cap. Now see, again, we'll cut this entire row, and now entire row and column of K cap we have cut. So again, what are we left with? We are left with these 4. So vertically down minus vertically up. This is how you have to remember it. So this is 3 into 0 minus 1 into 2. This is how you have to write. 3 into 0 minus 1 into 2. This is the way you have to write it. Now you can solve it further. See, this is what we have to obtain. Once this equation is achieved, we can solve it. See, 3 into 2 is 6. 6 minus 0 is 0. So 6 I cap. This is 9. 9 minus 1 is 8. So minus 8 J cap. All right. This is 0. 0 into minus 0 minus 2. So minus 2 K cap. This is how we have to write it. Copy this down, class. See the next portion, geometrical meaning of cross product. If just in case you get a question where you have geometrical meaning of cross product. So basically, you will be asked to write the area of a parallelogram, or you will be asked to write the area of the triangle. Because you know that a parallelogram is like this in shape, right? And triangle is half of it. So area of parallelogram directly becomes A into B. Whereas when you're talking about the area of the triangle, it is half into area of the parallelogram. All right, you just have to remember that area of the parallelogram is equal to double the area of the triangle. Fine. That's how you have to apply it. All right. So find A and B and the area of parallelogram having A and B as adjacent sides. So unit vector you have to calculate and then the area of the parallelogram. This I'll discuss. B means you basically have to find out the cross product. All right. So in this I have told you that cross product is cap, J cap, K cap you will write 1 for J cap, -2 for K cap. Okay. Next is 1 -1 -3. I'm not audible. Am I not? Yes, class. Can someone respond? Am I audible? Can you hear? It's clear now. Okay, so respond. The other students, yes, Adil and Ali. The class is for you too, no? So I cap has 1. This has -1. 1 minus 1 and -3. So this is the Cartesian system. Ali and I open the cameras. So when you are writing, we are left with these 4. So this minus this, basically 1 into 2. Then minus J cap. So for J cap, we cut this, we cut this. Then these 4 we have, right? So this minus this. 1 into -3 minus 1 into -2. All right, then plus K cap. This is cut, this is cut. We are left with these 4. So vertically down, minus vertically up. Remember for J cap, we have to write minus J cap. Do not write down plus for that. Okay, so this is 1 into -1 minus 1 into 1. So we get, what do we get? We have this is equal to -3, right? This is -3. This is 2. So 3 minus 2 is 1, I cap. This is -3. This is -2. Minus minus plus. So -3 plus 2 -1. -1 into minus J cap is plus J cap. Last one -1 -1 -2 K cap. What's the question? Perpendicular, yeah. So we have find a unit vector perpendicular both. So, what can we do? We can convert this into the unit vector plus j cap minus 2 k cap. So we can find out the unit vector. For that, we require the magnitude. How do we calculate the magnitude? Under root of the square of the coefficients. So 1 square plus 1 square plus minus 2 whole square. This is equal to 1 plus 1, 2. 2 plus 4, 6. Root 6. Okay. This is r vector divided by this. So this is equal to I cap plus j cap minus 2 k cap divided by root 6. This is the unit vector also which we have calculated. Area of parallelogram is A cross B, which we have found. But it is A cross B by 2. So for the second part, area is A cross B divided by 2. Means I cap plus j cap minus 2k cap divided by 2. This is the answer. Write it down. This completes with this. Now we'll start with projectile. Write it down from here. See, now in angular projection, there are certain rules which you have to remember. But before that, see, understand this motion of any object. This is known as projectile motion. Basically, this is motion in 2D. This is motion in 2D. Now, see, you have two things over here, class. When we are talking about projectile motion, firstly, suppose a body is moving. This is a ball which is moving, which has initial velocity as u. Now, class, this is making an angle theta with the ground, and this is the trajectory that is followed. This is the path that is covered. So what we do here, we'll divide it into its two components. U cos theta, which will be the x-axis component, and then the perpendicular one, which will be u sine theta. This will be u bar. All right. You will get many things like acceleration. One acceleration will be ax, one acceleration will be ay. Velocity also at any instant you will get vy, vx, and vy. Now the question is that we have so many things over here. We have the distance also here and everything. So how can we solve this? The first question, because you are going to have this only in the chapter, and it's a very short chapter. Today's class, tomorrow's class, and one more class I require it. So that will be completed. What do you need here is that basically certain conditions are there which are fixed for projectile motion. All right, that has to be fulfilled. When we are discussing projectile motion, those conditions have to be fulfilled. So those conditions I'll share with you right now. And accordingly, that the second question which I was saying, that how to solve it best manner, you have studied vectors, and that's why so urgently before even starting with projectile motion, I started with vectors, and I emphasized that all of you should study vectors properly. Reason is that class, you will be solving everything along x-axis separately. You know how to solve now in 1D, right? You will solve everything along y-axis separately. You also know how to solve questions along y-axis, right? Finally, when you'll have all the quantities along x-axis, y-axis, you know the rule under root a square plus b square. Because they are making an angle of 90 degree x and y-axis. That's the rule which you have to remember. Now, acceleration along x-axis will be 0. Acceleration along y-axis will be acceleration due to gravity. So all these things I'll tell you. First, just write down this page first. This is the introduction. Will give you an overview. Also, please update. Abir has only switched on her video. She's only the one who is giving updates. Ali and Adil, you both are also in the class. See, these are the conditions which you have to remember. Along x-axis, what all things you have to remember? There will be no change in the velocity along x-axis. Means no change in the velocity along x-axis means that ux will remain the same. This means, this first point means that ux, which is equal to u cos theta, this doesn't change. This will remain the same. Second, acceleration along x-axis is 0. Ax is 0, which we have studied, no? Ax. This point basically says that this only. Acceleration is 0. And see, if acceleration is 0, so F is equal to ma. Directly, Fx will also be 0. So these are the conditions you have to remember along x-axis. Next, along y-axis, what you have to remember? Two things. Firstly, acceleration which is acting. See, whenever acceleration is acting under the influence of gravity, this acceleration we call it acceleration due to gravity. So ay is basically g, which is the acceleration due to gravity. And see, at the highest point, basically what happens? Ball moves. At the highest point, the velocity along y-axis becomes 0. So ball starts coming down, not x, y. This becomes 0 at the highest. Down the conditions, class. See class, now equation of trajectory. What is the meaning of the term trajectory? Trajectory means path covered. So trajectory basically means the path covered, which is present. Now see, when we are having a particular trajectory, we have to solve everything along x-axis and y-axis separately. So along x-axis, when you are solving, ax is 0, as we have discussed. So when we are writing the equation, when we are writing this equation of s is equal to ut plus half at square, right? So here what we are going to do, s is equal to ut plus half at square. All this is for the x-axis. So x I have mentioned. Now ax is 0, so this term becomes 0. What is the displacement x which we are calculating? Ux, it is u cos theta into t, right? Why? You know, na, we have solved ux is actually u cos theta, right? So from here, t we can write as x divided by u cos theta. So this is the equation of time. So this is the first equation. You can keep it as it is. Second equation along y-axis. Now, whenever we have anything along y-axis, you have to remember if a body is coming down or the body is moving up, we have a particular sign convention. Now, if I choose upwards as positive and downwards is negative, so everything which is acting upwards, that will be positive for me, and anything which is acting downwards, it will be negative for me, right? So acceleration is acting downwards, so acceleration is negative. Uy, throwing the body up, so it is positive. So let me write down this. Y is u sine theta t minus half y minus this acceleration due to gravity t square. Now we have calculated the value of this t, right class? T is equal to x by u cos theta, है ना? So let us write down this value. So y will be equal to u sine theta t. What is t? T is x by u cos theta minus half g t square. If t is x by u cos theta, so t square will be x square by u square cos square theta. U will be cancelled. We have our final value of this equation. Y is equal to x tan theta. Why tan theta class? Because here we have sine theta by cos theta, right? So that is tan theta minus g x square divided by 2 u square cos square theta. This is the equation which you have to remember. What are the meanings? Y is the trajectory. Trajectory means what? Trajectory means this path covered. How will you calculate this? X is the x-axis. Tan theta, you know, theta is the angle of projection. I am mentioning here now. I won't be mentioning all the symbols in the next part. So in the exam, whenever you have this derivation, be careful to mention u is the initial velocity. U is the initial velocity and g is the acceleration due to gravity. Acceleration due to gravity. Fine. Write down this derivation, then we'll see other things. Write it. See class, when we are talking about the time of flight is basically the total time that takes by this projectile to reach from the starting point till the end. So time taken by the projectile to move from origin to the point where motion is stopped. That is, the entire duration is known as the time of flight. So again, we'll start with y is equal to ut plus half at square. So if we are talking about the y-axis, we'll write uy ay. Now see, there is actually no displacement along y-axis. If you look here, the body has reached the original position back. So this is again at the basic axis, all right? So uy is equal to, y is equal to 0. Because along x-axis, definitely there has been certain displacement, but along y-axis, we have no displacement. Okay, so uy is equal to u sine theta, ay is equal to minus g. So when you put this uyc 0, that is y is equal to u sine theta t minus g t square by 2. T is the total time of flight which we are calculating. So see, when this u sine theta will go on the other side, did you understand this? This is y is equal to u t plus half a t square. We have substituted it. So when this goes on the other side, t is equal to 2 u sine theta divided by, this is the formula for the time of flight. All right, time of flight. Fine. Write down this. Okay, I think this would be most probably the last portion. Let us see. What exactly is range? Range is, see, this was the initial point. This is the final point. So this horizontal distance which has been covered, that is referred to as the range of motion. So you will be seeing lot of terms, range is written. Basically, it's the range of motion. All right, this is the range of motion. So see, if we start with x-axis, x is equal to ut plus half at square. So since we are talking everything about x-axis, we'll write x everywhere, like ux, ax. Now, you know acceleration along x-axis is 0. So this becomes 0. So what are we left with now? See, what is the displacement along x-axis? It is r itself, right? That is now what we are studying, the horizontal distance along the x-axis. So it is what? It is r itself. So r is equal to uxt. That is u cos theta, and time we have already found that it is 2u sin theta by g. So if you solve this C class, there is an identity 2u, sorry, not even u can be put separately, 2 sin theta into cos theta. See, wait, let me write it. You have 2 sin theta into cos theta. So see, this can be written as sin square theta. Fine. Now see, when you have this, not sine square theta, wait, sine 2, now you substitute r is equal to u into u becomes u square sine 2 theta by g. That is the formula for range of motion. Suppose our theta is maximum. We are calculating it for maximum range. So sine 2 theta is present. If theta is equal to 45 degrees, then 2 theta will be equal to 90 degree, right? Then only we can say sine 90 is equal to 1 and we'll get the maximum range, which is u square by g. Fine. Write down till here. All right, class. Then we'll complete the next portion tomorrow. Okay, some portions are left, and angular projection will be over. All right. Thank